Okay, pre-calculus 10, let's get after it. We are going to factor using the greatest common factor. So to start off, what we're looking at is we're looking at things that have greatest common factors. We are reverse water bombing. So remember when we looked at the act of water bombing, and the most abstract example we gave was a times b plus c, and we multiplied the a in and we got a times b plus a times c. So ideally, what you're considering is you're looking at this, and that is the product AB with factors A and B, and that is the product AC with factors A and C. Do they have a common factor? Yes, A and A. So if we were working backwards, we can reverse water bomb an A out of that, and we would get back to that. So you're essentially looking at what can I factor out of both. Factoring is very similar to division, except it's not being divided out. It's just being factored out of brackets, essentially. You are hitting rewind and you're watching the water bombing go in the opposite direction. So you're trying to find a common factor. So let's look at 5x plus 10 down at the bottom right here. Okay, that means 5 times x, and I'm only going to do it this way for this first question. 10 means 2 times 5. Is there a common factor there? Yes, a 5 in both. So a 5 can be factored out, and what's left on the inside? An x plus 2. And you can always check these. I mean, okay, well, what would happen if I were to water bomb back in? You end up back to the 5x plus 10. So that's your goal. Okay, you are looking for a factor that is common to every single term that you're looking at. So if we look here at the 3x squared, well, you can do this kind of piecewise too. You can look and say, well, a 3 is common to both, but so is an x. Okay, so then what's left on this first one, right? A 3 and an x came out. That means, well, an x is left, and a 3 and an x came out of there, so that means a minus 2 is left. And if you water bomb that back in, you get 3x squared minus 6x. So the common factor in that case is 3x. Now, if we look at the last one, I'll break this one down to, right, 12 is 4 times 3, 8 is 4 times 2, and 4, well, it's 4 times 1, so common factor. So a 4 is coming out. And then if you look at x to the power 4, x to the power 3, and x to the power of 2, well, all of those has an x to the power of 2 as a factor. So an x squared comes out. So what are we left with? We're left with 3x squared minus 2x plus, and this is really important, I factored all of that out. So what's left in there? A 1. You have to put the 1, because if you don't put the 1, there's nothing to water bomb back into. Okay, so the 1's really important. So this is factoring by removing the greatest common factor. So it can be more than just a term. It can be a whole binomial. And I'm going to show 2 ways here. This first one, I'm just going to be like, okay, look, this is a factor, right? It's all of this times x, and it's all of this times 3, right? So we can water bomb out all of that, and we're left with x plus 3. Now that might seem a little weird, but imagine if you multiply this whole thing back into here, you end up with that scenario. And if you multiply it into here, you end up with that scenario. So you can water bomb out an entire thing. What I'm going to do for this second question here is I'm going to use substitution to maybe make this look a little clearer. The funny thing is, making it look clearer can also make it look more confusing. And I'm just going to go like this. Let y minus 3 as a binomial be equal to a different variable. I'm going to say let it be equal to the letter t. Because what I can do is I can substitute the letter t in everywhere I saw that y minus 3. Right? So this is now represented by the letter t, and this is now represented by the letter t. It just makes what you're looking at cleaner, because now you can see that that is a common factor. So a t comes out, and you're left with 6y plus 5. But when you're done there, you then have to sub back in for what you replaced t with, which in this case was y minus 3. So what I've done is I've just factored out the binomial, just like I did in the first question over here. I just did it using substitution to make the question look cleaner. For a lot of people's brains, it makes life look a lot easier, but that is an option for you as well. So this is another thing called factor by grouping. Now, if you're ever given 4 terms, you can see here we have 4 terms, or realistically an even number of terms, but you won't normally see it with anything more than 4. You can group certain things together and factor out something in common. And what I'm going to do is I'm actually going to show this to you in 2 ways, because it shows you that it doesn't matter how you group them in a sense. So what you do is you take this statement, okay, and you group pairs of the things together. Now, this doesn't mean we've turned it into multiplication. It just means we're showing a separation of our groups, okay? Because that doesn't mean I'm now multiplying this by this. That's not what's happening. I'm just demonstrating that I've broken it into 2 groups. But what you do is you factor out something common from that group. Well, what's common to both of those things? An x squared. And what's left? X plus 1. And then what's common to both of these things? A plus 3. And the sign is really important because it gets us back to an addition or subtraction statement and not a multiplication statement. And we end up with x plus 1. So you can see by grouping these things, we have now factored out something common. And now we have a common binomial factor. And I can factor that out. And I'm left with x squared plus 3. And that is the factored form of this thing. So this is factored by grouping. You're going to see it again. Again, it's not something I expect you to be comfortable or confident with right away, but it's something that you are going to want to get comfortable and confident with. So just to reiterate, if I were to rearrange these 2 terms, okay, rearrange, you're allowed to do that. So say I had the expression written like this instead. I would still put the brackets around, and I'm looking for common factors. Well, this time, if I look here, the only common factor I have is an x. So I would factor out an x, and I'd be left with x squared plus 3. But then if you look at this one, I do not have a common factor. But you do, it's just the number 1. So you can factor out a plus 1, because you'll notice what that leaves is still a x squared plus 3. What that does is that gives me a common binomial here still, and it allows me to factor it out and still be left with an x plus 1. And you'll see that the 2 answers here are exactly the same, just order is reversed. So you have a little bit of a margin for error there, but it's something that there's lots of practice in the workbook for you to kind of get comfortable with. Here's another one. So let's just go, group those 2 and group those 2. So what can you factor out of the first set? Well, they both have an x squared, so you can factor an x squared out, but you can also factor out a 2. And what you'll be left with is x minus 3. And now here again, if you look at this one, I already have x minus 3, but I need to still factor something out. I'm going to factor out just a plus 1. And I get x minus 3. It's important that you factor out that plus 1, because even if you do that, right, you'll still end up with the same expression. But if you don't factor out that plus 1, you'll have nothing to factor out of with respect to binomial and binomial, because that x minus 3 gets factored out of 2 terms, the 2x squared and the plus 1, and that's what allows you to factor it out. So it's important that that 1 is present. There's another scenario where you might see it as a negative 1, and maybe we have one here, but you'll definitely have one in your workbooks. This could be an example. It is right here. In a sense, here I have those 2 terms, and I have those 2 terms. So from the first one, I can factor out an a, and I'm left with a plus b. So what you're looking for is, what can I factor out of here so that I'm left with A plus B because I want to have the same binomial. Now you'll notice this is a negative and here it's a positive, which means I'm not going to be factoring out a positive number. I'm going to be factoring out a negative number. But then I'm also factoring out a 2. So minus 2 comes out because if you water bomb that back in, it would change the signs to negative. So what you've done now is you've created a scenario where you have a negative number on the outside, and then we still factor the binomial. We factor this whole thing out of the a and the minus 2. So it works. Sometimes that could just be, right? Sometimes that might just be a negative 1. So just be prepared for that. It's similar to this scenario, except this becomes a negative 1 instead of a positive 1. Lots happening here. This is going to take a lot of practice, which is why we spend 3 whole sections on this. It's because it's really important, but also there's a lot of little intricacies. So this is section 5.3. Get as comfortable as you can with the factor by grouping, but we're going to see it again where we're going to have to actually create the 4-term scenarios. If you have 4 terms, you can group. If you only have 3 terms, you're going to have to create the 4-term scenario, which we'll look at in a couple videos from now. But keep on learning, keep on working, and we will continue to make positive progress.